Unlike electric clothes dryers, which have a demand factor of 50%, there is no specific demand factor established for tanning beds in the National Electrical Code, or NEC. To determine the total amperage for a tanning salon, follow these steps. Firstly, sum the amperage of each bed. Obtain the amperage rating from the manufacturer's specifications for each tanning bed. Secondly, multiply by number of beds. Multiply the amperage of each bed by the total number of beds. Thirdly, apply a diversity factor. This is optional. If the beds are not all operated simultaneously, apply a diversity factor. A common value is 80%, which assumes that only 80% of the beds will be in use at any given time. However, this value can vary depending on the specific salon's operating patterns. The formula is total amperage equals summed amperage of beds times number of beds times diversity factor. For example, if you have 10 tanning beds, each rated of 15 amps, and a diversity factor of 80%, the total amperage equals 15 amps times 10 beds times 0.8, which equals 120 amps. The actual load may be different depending on the type and size of the tanning beds used. It is recommended to consult with a qualified electrician for a professional load calculation. To elaborate further on calculating the electrical load for tanning beds, let's delve into the specifics of each step. When summing the amperage of each bed, it is crucial to gather accurate information from the manufacturer's specifications. This data typically includes the voltage and amperage requirements for each tanning bed model. It is essential to use the most up-to-date specifications, as older models may have different power requirements than newer ones. Once you have the amperage rating for each tanning bed, you need to multiply it by the total number of beds in the salon. This calculation gives you the total amperage if all the beds were to operate simultaneously at their maximum power. However, in most tanning salons, it is unlikely that all beds will be in use at the same time. This is where the diversity factor comes into play. A diversity factor is a percentage that estimates the proportion of tanning beds that will be in use simultaneously. The diversity factor can vary depending on the specific salon's operating patterns. Factors that can influence the diversity factor include the salon's location, the time of day of the week, and the season. For example, a tanning salon located in a tourist area may experience high usage during peak season compared to the off-season. Similarly, a salon that offers discounts during certain hours may see a high concentration of customers during those times. To determine an appropriate diversity factor for a specific tanning salon, it is best to observe the salon's operating patterns over a period of time. This can involve tracking the number of beds in use at different times of the day and week. Based on this data, you can calculate the average percentage of beds in use simultaneously. This average percentage can then be used as the diversity factor. If historical data is unavailable, a common practice is to use a diversity factor of 80%, as mentioned earlier. This assumes that only 80% of the tanning beds will be in use at any given time. However, it is important to note that this is just an estimate, and the actual diversity factor may be higher or lower depending on the specific salon's operating patterns. Once you have determined the appropriate diversity factor, you can apply it to the total amperage calculation. This involves multiplying the total amperage by the diversity factor. The resulting value is the estimated maximum amperage that the tanning salon will draw at any given time. This value is then used to determine the size of the electrical service required for the salon. It is important to consult with a qualified electrician to ensure that the electrical service is adequate to handle the load. The electrician will take into account other factors, such as the lighting, air conditioning, and other electrical equipment in the salon. They will also ensure that the electrical installation complies with all applicable codes and regulations. In addition to calculating the electrical load for the tanning beds, it is also important to consider the voltage requirements. Tanning beds typically operate at 208 volts, 240 volts, or 277 volts. It is essential to ensure that the electrical service provides the correct voltage for the tanning beds. Using the wrong voltage can damage the equipment and create a safety hazard. Furthermore, it is crucial to use appropriately sized wiring for the tanning beds. The wiring must be able to handle the amperage draw of the beds without overheating. The National Electrical Code, or NEC, provides guidance on wire sizing. It is important to follow the NEC guidelines to ensure that the wiring is safe and reliable. In addition to the wiring, it is also important to use appropriate overcurrent protection devices, such as circuit breakers or fuses. These devices protect the electrical system from overloads and short circuits. The overcurrent protection devices must be sized correctly to protect the wiring and equipment. Again, the NEC provides guidance on overcurrent protection device sizing. Finally, it is essential to have a qualified electrician inspect the electrical installation to ensure that it is safe and compliant with all applicable codes and regulations. A qualified electrician can identify potential hazards and make recommendations to improve the safety and reliability of the electrical system. In summary, calculating the electrical load for tanning beds requires careful attention to detail. It is important to gather accurate information from the manufacturer's specifications, determine an appropriate diversity factor, and consult with a qualified electrician. By following these steps, you can ensure that the electrical system is adequate to handle the load and that the tanning salon operates safely and reliably. When considering the National Electrical Code, or NEC, and its implications for tanning bed installations, it's important to recognize that while a specific demand factor for tanning beds is not explicitly outlined like it is for electric dryers, the general principles of load calculation and safety still apply. The NEC provides the framework for safe electrical installations, and electricians must use their professional judgment and knowledge of the code to ensure compliance. This includes selecting the appropriate wire size, conduit, overcurrent protection, and other electrical components. Moreover, proper grounding and bonding are critical for safety in tanning salon environments, as are adherence to arc flash hazard mitigation practices. The NEC also addresses the requirements for dedicated circuits for specific types of equipment, which might be applicable to tanning beds depending on their power requirements. It's also important to note that local codes and regulations may have additional requirements beyond the NEC. Therefore, it's crucial to consult with local authorities and obtain the necessary permits before installing any electrical equipment. To further illustrate the importance of accurate load calculations, let's consider a scenario where the calculated load is underestimated. If the electrical service is not adequately sized to handle the actual load, it can lead to several problems. Firstly, the circuit breakers may trip frequently, interrupting the operation of the tanning beds. This can be frustrating for customers and result in lost revenue for the salon owner. Secondly, the wiring may overheat, which can damage the insulation and create a fire hazard. Thirdly, the voltage may drop, which can cause the tanning beds to operate inefficiently and shorten their lifespan. On the other hand, if the calculated load is overestimated, it can result in unnecessary expenses. The salon owner may end up paying for a larger electrical service than is actually needed. This can increase the initial cost of the installation as well as the ongoing electricity bills. Therefore, it's important to strike a balance between ensuring that the electrical service is adequate to handle the load and avoiding unnecessary expenses. A qualified electrician can help you determine the optimal size of the electrical service based on the specific needs of your tanning salon. Another important consideration is the potential for future expansion. If the salon owner plans to add more tanning beds in the future, it's important to factor this into the load calculation. It's generally a good idea to size the electrical service to accommodate future growth, as it can be more expensive to upgrade the service later on. In addition to the tanning beds, it's also important to consider the other electrical loads in the salon, such as the lighting, air conditioning, and other electrical equipment. These loads can add up quickly, and it's important to include them in the total load calculation. To ensure accuracy, it's best to create a detailed list of all the electrical equipment in the salon and their respective amperage ratings. This list can then be used to calculate the total load. Finally, it's important to remember that electrical work can be dangerous. It's always best to hire a qualified electrician to perform any electrical installations or repairs. A qualified electrician has the knowledge, skills, and experience to perform the work safely and correctly. They will also ensure that the installation complies with all applicable codes and regulations. This ensures the safety of the tanning salon's customers and staff and prevents potential electrical hazards. Consider a tanning salon owner who decides to install 10 new tanning beds. Each bed requires a dedicated 20 amp circuit at 240 volts. The existing electrical panel has limited capacity, and the owner wants to avoid a costly upgrade to the main service. The owner consults with a licensed electrician to perform a load calculation and determine the best course of action. The electrician begins by gathering the specifications for each tanning bed, noting the voltage, amperage, and any specific requirements from the manufacturer. They then assess the existing electrical panel, identifying the available breaker spaces and the capacity of the existing circuits. Next, the electrician calculates the total load of the new tanning beds, taking into account the possibility of all beds operating simultaneously. They also consider the existing load of the salon, including lighting, air conditioning, and other equipment. Based on the load calculation, the electrician determines that the existing electrical panel does not have sufficient capacity to handle the new tanning beds without an upgrade. They present the owner with several options, including upgrading the main service, installing a subpanel, or implementing a load management system. After considering the costs and benefits of each option, the owner decides to install a subpanel to accommodate the new tanning beds. The electrician installs the subpanel, ensuring that it is properly grounded and bonded. They then run new circuits from the subpanel to each tanning bed, using appropriately sized wiring and overcurrent protection devices. Finally, the electrician tests the entire system to ensure that it is functioning properly and safely. The owner is pleased with the results, as the new tanning beds can operate without overloading the electrical system. The installation is also in compliance with all applicable codes and regulations, providing peace of mind for the owner and their customers. Without a proper load calculation and professional installation, the owner could have faced serious electrical problems, including overloaded circuits, damaged equipment, and potential fire hazards. This example highlights the importance of working with a qualified electrician and following proper electrical practices. When performing load calculations for tanning salons, electricians must consider several specific factors that are unique to these types of businesses. Firstly, the tanning beds themselves are high-power devices that draw significant amounts of current. It's crucial to use accurate amperage ratings from the manufacturer's specifications to avoid underestimating the load. Secondly, tanning salons often have multiple tanning beds operating simultaneously. This can create a significant demand on the electrical system, especially during peak hours. Therefore, it's important to consider the diversity factor, which is the percentage of tanning beds that are expected to be in use at any given time. Thirdly, tanning beds may have specific voltage requirements, such as 208 volts, 240 volts, or 277 volts. It's crucial to ensure that the electrical system provides the correct voltage to avoid damaging the equipment. Fourthly, tanning salons may have other electrical loads, such as lighting, air conditioning, and ventilation systems. These loads must also be included in the load calculation. Fifthly, local codes and regulations may have specific requirements for tanning salon electrical installations. It's important to consult with local authorities to ensure compliance. In addition to these specific factors, electricians must also consider general electrical safety practices such as proper grounding, bonding, and overcurrent protection. These practices are essential to prevent electrical shocks, fires, and other hazards. By carefully considering all of these factors, electricians can ensure that tanning salon electrical installations are safe, reliable, and compliant with all applicable codes and regulations. The complexity of electrical load calculations for tanning salons highlights the importance of professional expertise. While it might be tempting to attempt a DIY installation to save money, the risks associated with improper electrical work are simply too great. A qualified electrician has the training, experience, and equipment necessary to perform the work safely and correctly. They can also provide valuable advice on energy efficiency, code compliance, and other important considerations. Moreover, hiring a licensed electrician can protect the salon owner from liability in case of an electrical accident or fire. Electrical work is inherently dangerous, and it's always best to leave it to the professionals.